Our final method for solving quadratic equations is by the quadratic formula. Like completing the square, the quadratic formula will work for every quadratic equation. Note, while solving quadratic equations by completing the square can be a lot of fun, I know you agree with that, it can also be tedious. You probably agree with that as well. So let's solve the general quadratic equation, ax squared plus bx plus c equals 0, by completing the square to see what happens. So instead of having numerical coefficients here, we have general representatives. So we have ax squared plus bx plus c equals 0. My goal is to solve this equation following the same steps that we learned in the previous video, completing the square. Remember, the first thing that we look for is a leading coefficient. In this case, our leading coefficient is a. It's not equal to 1. So we need to clear that coefficient. So I'm going to divide all of our terms through by a on both sides. That gives us a quadratic equation with a leading coefficient of 1. So we have x squared plus, now bx over a could also be written b over ax. You can see the coefficient there is b over a and the variable term is x. Now I'm doing two steps in one on this one. We know when we're completing the square that we need the quadratic and linear terms together on one side and the constant on the other. So I'm going to go ahead and subtract my constant term from both sides here. Then we're ready to complete the square. So I need to find the magic number that I can add to both sides of this equation that will complete the square. We got to keep it balanced by adding it to both sides of the equation. Okay, so how do we find that number? Remember from our algorithm, we take the linear coefficient, which in this case is b over a, and we're going to divide it by 2 and square it. Now, instead of dividing by 2, since I've got a fraction here, I'm going to do the equivalent and multiply by a half. So I'm essentially dividing by 2 and squaring. So multiplying the fractions, we have b over 2a squared. And squaring the top gives me b squared, and squaring the bottom gives me 4a squared. So that's the magic number that I want to add to both sides. So we have b squared over 4a squared here. That completes the square on the left. And we're going to add it over here to keep it balanced. Now remember, we have created a perfect square trinomial on the left side. Our next step is to factor it. Because it's a perfect square trinomial, we know that it's going to factor as the square of some binomial. Now remember the process. Don't be overwhelmed, just remember the process. The first term in my factor is always the square root of this term, which is just x. Remember, the sign in my binomial factor matches the first sign in my trinomial. And the second term in my factor is the square root of this term. Now don't forget, we just saw that number over here. So this factors as x plus b over 2a quantity squared. Okay, that wasn't so bad. On the right side, we need to combine these two fractions, which is going to require a common denominator. So between a and 4a squared, our common denominator is 4a squared. The second fraction already has that denominator, so there's no update required on that one. But my first denominator has been multiplied by 4a to get 4a squared, so I need to apply that to the numerator as well. So 4a times negative c gives me negative 4ac. So at this point, we have x plus b over 2a quantity squared equals, we can make this one fraction with the common denominator of 4a squared, and then I'm going to lead with the positive term, b squared minus 4ac, to make it readable. The next step in completing the square is to take the square root of both sides, including the plus or minus. Now the square root of something squared, as you know, leaves behind just the base, x plus b over 2a. And on the right side, we can split that radical over the top and the bottom. So we have the square root of b squared minus 4ac over the square root of 4a squared in the bottom. Now, we can simplify that square root on the bottom. No change to the numerator, but the denominator is equal to 2a. Now, to finish, we'll subtract b over 2a from both sides, and we'll put it in front of that plus or minus. So we have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then because those two terms have a common denominator, we might as well combine them into a single fraction. And we have negative b plus or minus the square root of b squared minus 4ac all over 2a. If you know anything about college algebra, you will recognize that is our quadratic formula. So by solving this general quadratic equation with coefficients a, b, and c, we have a general formula that will solve any quadratic equation. So if I know the coefficients a, b, and c, now I can just plug them into this formula, evaluate the arithmetic, skipping the algebra, and have the two solutions. So you'll definitely want to memorize not this proof. I hope you enjoyed it, but don't panic. You don't have to memorize the proof, but you do need to memorize the formula. So the solutions to the quadratic equation ax squared plus bx plus c, notice it is equal to 0, are given by x is equal to, I'm going to sing it to you. Are you ready? It's To Pop Goes the Weasel. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, you're welcome for that. I hope you sing it all day, but I do hope that helps you to memorize it. Note the radicand, b squared minus 4ac, is what we call the discriminant. Just a little vocabulary for you here. It helps us to determine if the solutions are real or complex. So if that number is positive, we're going to get two real solutions. If it's 0, we're going to get something called a repeated root. And if it's negative, we'll get two complex solutions. So I think this process, even though the proof may have been a little rigorous, the process of solving a quadratic equation with the quadratic formula is pretty straightforward. So let's give it a try. Solve the following quadratic equations using the quadratic formula. So we have x squared minus x equals 1. An important thing to recognize about the quadratic formula is that it only works if all of my terms are in one side and equal to 0. So remember, if I'm going to factor, I need it equal to 0. If I'm going to use the quadratic formula, we also need it equal to 0. So now we're going to identify our coefficients. So the leading coefficient A is equal to 1. That's this number right here. B, the coefficient of my linear term, is negative 1. And C, the constant term, is negative 1. So we're going to plug these into our quadratic formula. So I want to rewrite it right here. I hope you're singing the song. And then I can see what goes where. So plugging in negative 1 for b, now be careful here, I'm going to copy the negative from the formula, and then I'm going to replace b with negative 1. So I get a double negative right there. Plus or minus the square root. Now I'm going to square b. Since it's negative, I want to keep it in parentheses. Minus 4 times a, which is 1, and c, which is negative 1. All divided by 2 times a, which is 1. This is what we call plug and chug, right? You plug it in and you work your way through the arithmetic. So thinking about order of operations, we got a double negative here. Let's call that a positive 1. And under the radical, we have negative 1 squared minus 4 times negative 1. That's 1 plus 4. I'll write the steps here. 1 plus 4 all over 2. So finishing out, we have x equals 1 plus or minus the square root of 5 over 2. So the two solutions to my quadratic equation are 1 plus or minus the square root of 5 over 2. Notice all that required was arithmetic. We didn't do any algebra. We weren't factoring. We weren't taking the square root of both sides. That's because we did all the work in general by deriving that quadratic formula, and now we have the benefit of a very easy solution. Now, keep these two numbers in mind, 1 plus or minus square root of 5 over 2. This is actually a very famous irrational number, and we'll talk about that on example 6 in the next video. Let's do another example using the quadratic formula. So this one may at first appear to be linear because x is raised to the power of 1, but if we carry out the distribution, we can very clearly see, yep, it is quadratic. We have 5x squared, there's my quadratic term, minus 4x equals negative 2. Moving the negative 2 to the left side, by adding it to both sides, we now have it equal to 0. Now it's in a form where I can apply the quadratic formula. So our leading coefficient A is 5, B is negative 4, and C is 2. So I've got my formula in view over here. So with that as my guide, I'm going to plug in these new values for our coefficients. So we start with negative B. That's going to be the negative from the formula, and we're replacing B with negative 4. Plus or minus the square root of b squared, keep b in parentheses, minus 4 times a, which is 5, and c, which is 2, all divided by 2 times a. So that's our setup. Let's work on the arithmetic. Negative negative 4 is positive 4. Under the radical, we have 16 minus 4 times 5 times 2 gives me 40. All divided by 10. And 16 minus 40 gives me negative 24, all divided by 10. And because we have a negative under the radical, we're going to extract that as an I. We can say 4 plus or minus I square root of 24 divided by 10. Now let's work on reducing the square root of 24. So I'm going to think of the square root of 24 as the square root of 4 times 6. So we can break up our radical and obtain 2 square root of 6. So back to our solution, we have 4 plus or minus 2i square root of 6 over 10. Now, because it's imaginary, we are required to split it up into 2 separate terms. We didn't have to do that on this example because it was not an imaginary number. It's just an ordinary irrational number. But over here, to keep our complex numbers in standard form, we will split it up into 2 fractions. So each term in the numerator gets the same denominator. And when we reduce our fractions, we have 2/5 plus or minus I square root of 6 over 5. So those are our 2 solutions. All right, so that is the 4 methods. Factoring, square root method, those 2 are convenient and efficient, but they don't always work. And then we have completing the square and the quadratic formula, maybe a little more tedious, but always reliable. They will solve every quadratic equation.